Hey guys, so this is the second of what I determined will be three different problems um, dealing with friction, and this is a different type of problem, one we haven't seen really, but actually, hopefully, you'll actually find it a little bit easier. So, this problem we have a 0.68 kilogram puck, so that is its mass, and it's sliding on the ice but slowing down at a rate of, you see those meters per second squared, of 0.91 meters per second squared. Slowing down, though, tells you that number should be negative. We have to find the friction force and determine the coefficient of friction between the ice and the puck. So we have to find friction and we have to find mu k. Alright, so first, to do this, a couple of different directions you can go, but when I see mass and acceleration, I automatically calculate the net force. The net force, which by Newton's second law is 0.68 times 0.91, which is negative 0.618 or 0.6188, so 0.619 newtons. Alright, so what do we do with that? Well, this hockey puck is sliding, like I said, usually we go to the right if it's moving, which means that if it's slowing down, our acceleration is backwards. So our net force diagram, or our free body diagram, will have three forces. It'll have the weight, the normal force, which perfectly balance each other, and the same direction of the acceleration will be the direction of our net force. But our net force, you don't put on the free body diagram. You use the free body diagram to calculate the net force. And since there's only one force trying to slow this thing down, because the problem doesn't say anything about an applied force, this net force is really a friction force. But what friction force? Is it FFS or is it FFK? Well, the key thing that it says in this problem is right there. Sliding. Sliding tells you that it's moving. Moving tells you that it is our kinetic friction force that we have to deal with. Alright, so we have our free body diagram. We have to determine the values. Well, first to figure out the weight. Weight is mass times 9.8. That's going to be 6.66. Now that was an unintentional 6.66 newtons, which means our normal force is 6.66 newtons. So that gives us canceling forces vertically, which means our net force is the only thing that's acting backwards, and we know that our net force, which equals our force of kinetic friction, is equal to 0.618 newtons. 0.618. Alright, so that is our friction force, and we know that it is a kinetic friction force. So that's the first part of the problem. To determine the coefficient of friction, once we know this friction force from our free body diagram, using Newton's second law to determine what the net force was, using the free body diagram to realize that the net force is the same as the friction force, we can simply plug into our FFK equals mu k times the normal force to determine what the coefficient is. So we're trying to find the coefficient. Simple math should show you that mu k is the force of friction over the normal force. Force of friction 0.618. Normal force 6.66, which equals 0.0933. And there are no units associated with the coefficient of friction. Sorry guys, I'm really tired tonight. Newtons over newtons. Both of the forces have units of newtons. Obviously those forces cancel, which leaves us with a unitless number. So this is the one time, or one of the very few times in this class where you should have no units on an answer. Coefficient of kinetic friction is 0.093. And as I've said in class, it should be less than 1 and greater than 0. And it is. So we're good. All right, perfect. Relatively simple problem. The final problem is going to be a little bit more complicated. Have kind of the same idea, though.